So for this topic, I will be discussing about CFD simulation of exhaust expired air from a passenger inside an open-air vehicle. So I will be discussing the current problem that the Philippines is having right now on using a jeepney and reducing the social distancing by from 1.5 meters to 0.75 meters or till further to zero point 0.3 meters. So I have set up a CFD simulation to demonstrate or to see what will be the flow velocity and the mass concentration of expired air inside the vehicle. So I have set up this vehicle and I have four passengers 1.5 meters apart. So I have used side barriers in between the passengers and center barrier in front of the each passengers. So there's a wind direction at 5 meters per second, but I will also be simulating if there's no wind or to simulate that if the vehicle is at full stop. So the following are should be considered or should be answered during the simulation. Are we safe in reducing the sitting distance? Where will be the droplets stay after exhausting by the sneezer? Will the barrier help deflect the droplets? So I will be also doing a simulation at 0.75 meter distance with an increased capacity from 4 to 6 passengers. So let's discuss the CFD simulation results. The basis will be the flow velocity and the concentration of mass fraction of expired air. So as you can see, this is an overview of the CFD analysis. There's a flow velocity from the sneezer and there's a wind velocity acting on the vehicle. So for a 6-passenger vehicle, we'll see that there's a wind velocity flowing through the vehicle and there's a sneezer which is in the middle part of the simulation. Okay, so as a result of our CFD, I will focus first on velocity. As you can see, at 1.5 meter distance, no wind velocity, no barrier. This is high risk because there's a direct flow from passenger A to passenger B, wherein passenger A is the sneezer. There's high velocity of sneeze coming or pointing towards the passenger B. At no wind velocity with 1.5 meter distance and with barrier, passenger B is protected. But if the vehicle is already moving with 5 meters per second wind velocity, you'll see at no barrier, there's low risk of directing the sneeze towards passenger B. And on the same side with the barrier, you'll see there's low risk of passing the droplets to the passenger B to the side passengers because of the barriers. But if we will reduce it to 0.75 meter distance with barrier with wind, you can see that there's still low risk of directing the sneeze to your co-passengers and as well as with the center barrier only with wind. You can see, but this one is at high risk, especially if the vehicle is not moving. For the results of the mass fraction of air, you could see that the mass fraction of air will stay lesser because there's no barrier. You can see that. And for with barriers at a stationary vehicle, you could see that there's higher concentration of expired air at this passenger A. Then at 1.5 meter distance, you could see that at 5 meters wind velocity, you can see that with no barrier, there's low concentration of expired air, meaning the expired air is not staying longer inside the vehicle. And if for this simulation, you could see the concentration of expired air because there's a barrier that makes the droplets stay longer inside the vehicle. So there's high concentration of expired air, mid to high. And at a reduced distance, you could see that there's a concentration of expired air with the side barrier and center barrier, this one, and could probably go to the passenger B. So, but at lesser concentration. But if you will remove the side barrier, you could see that there's a low concentration of droplets with center barrier only. So with this, could say that Without barrier, passenger in front of the sneezer is not protected. Side barrier promotes for higher concentration of expired air. However, the distance in between reduce the risk. So there's 1.5 meters, but still there's a higher concentration of expired air with the side barrier. So for open air vehicle, use of center barrier only is better. Okay? So it reduces direct flow of expired air and do not promote high mass expired air concentration. So the 0.75 meters still works, but I don't recommend it to be reduced up to zero point 0.5 because as you can see, if you do it at zero point 0.5, there will be the droplets concentration will be nearer to each other. So I think 0.75 meter is the least distance that we can do. But definitely, always wear your face mask as it will make your droplets go down and will not make this be distributed inside the vehicle, and face shield will be an added protection to deflect direct droplets. So with this, I recommend that at least we could reduce the social distancing by 0.75 meters, and for jeepneys we could just use only points center barriers. Thank you.